One of the details here I want you to pay attention to is the top of wall down to the first course of insulation is a 3-inch gap in which the waterproofing is exposed. This is an important detail for our foundation, and as you instruct the waterproofing contractor, they need to leave the insulation down 3 inches from top of the wall. This allows the peel and stick membrane on the above grade framing wall to overlap and connect to that membrane down below. Additionally, we have the second layer, the outer layer of insulation, staggered down another 3, in this case 6 inches. But the key there is everywhere where we use the insulation, we're doing it in 2 layers, and we're staggering seams, and we're taping those seams in between layers as well. In this system, you're seeing 2 layers of extruded polystyrene. This is in the old days, like 2014, when they didn't have the drain requirements.
Why do we see 2 colors?
That's a really good question. I think it's just it's inventory.
I mean, are they different foam?
No, they're 2 different brands. Yeah.
Brands.
You'll see some other. I got some really good photos of them just sort of burning up inventory on the job site. We have one foundation where it's 3 layers of 1 inch, just on one wall. In theory, it's all the same, right? This is what that same assembly looks like when the structure is sitting on top of it. In this assembly, what you're seeing is 2 inches of it extruded up against the foundation, and then 1 3/8 drain board, which is like a compressed fiberglass board up on the outside. The other thing that we're going to be doing in the foundation before we pour the slab, in addition to sort of water and waste and the below slab waste drains, we're going to be installing a radon ventilation system. This is going to be an active system. This is a picture of basically like an installation boot. And so what the idea is that this is a stub-up boot that you can set into the gravel. It's got a perforated drain tile pipe that runs, let's say, 5 feet one direction, 5 feet the next, and then a 4-inch pipe that just sort of stubs up. And then you can place that. This boot has on it, it's not readily available here, but 4 tabs that you can drive a rebar or stake down in the ground to hold that thing steady during the pour. So we can place that thing accurately wherever we have the layout of the lower level framing. Okay.
So you're not tying that into the perimeter system?
Nope. No, so my take on the radon system, and generally what I see in radon systems, is that a lot of people like to tie into the sump.
Right.
And the sump pit creates a different fan curve requirement than the field, let's say. So when you dump into the sump pit and you've got really good communication throughout the subslab environment, you might not have a problem getting communication throughout the entire slab. But a lot of times, particularly on retrofit, when you drop into the sump, you're pulling air with little resistance through the drain tile system, and you're not actually penetrating into the field of the subslab. So if you were then to penetrate into the subslab and to pull and to get communication through, you'd see that you would need a much higher suction, lower volume fan to get that done. So knowing that we want to try to cover ventilation from the largest area that we want, we don't want to direct that necessarily just out to the perimeter drain tile. We want that system to behave differently, right? So as a rule of thumb and general practice, I like to put it into the field. But the other thing is that if we go to the sump, then we've got another pipe coming up and running over across where we'd like to bring this right underneath that wet wall framing in the basement. It just makes the pipe cleaner. It's a straight shot right up into the attic, less bends and curves in it. So that's the thinking behind that.
You're preferentially pulling through the rock, again, why the rock has to be large and no fines,
right, rather
than perimeter drain. But it'll reach the perimeter drain.
Yeah, in this build, because we're doing the details that we are, it's not going to have that problem. Backfill around that exterior drain tile, an important detail that we want and should be good practice for everybody is to cover that the gravel backfill that's around the drain tile with a landscape or a silt fabric to keep the fines from clogging that system up. It just once again provides a much better path with little resistance for the water to get out. and then basically the pour of the foundation. The next step we're going to talk about here is the structure. And on the structure, one of the big shifts that we got to make. Yep.
Before we pop out there, one of the nice things with the exterior insulation is you actually will have access to the slab wall joint after the fact. So after the concrete's cured, and it will probably pull away from the wall just slightly, then you can just run around with a urethane caulk and caulk that exterior control joint and again seal up. So when we talk about air, water, vapor, thermal, the air barrier for the slab is the concrete. And you gotta think about that being your air barrier. So the control joints need to be, you go back and seal those, that edge crack, slab edge crack has to be sealed after the fact. But again, since there's no framing there, it's easy to do, or at least make sure you do it before you add framing.
And what you see here is then the concrete contractor is basically just taking the poly and they ran it up the wall and they taped it to the wall. So at this point, you'd have to come back and cut that poly down, right? And we're not running any sort of like vent mat in between that to get, intentionally we want that gap sealed. Same thing with like your sump basket. Your sump basket's going to be let's see here if I've got a. Your sump basket should be sealed because this will have communication to that sub-slab environment. We could lose pressure on the radon fan, but any of those penetrations coming up through the foundation, we want those caulked and sealed to make sure that we've got good communication with that fan. Okay. Sorry, before I go on to the structure, I forgot about the egress wall I want to talk about. So we also will have on the egress assembly in the sequencing of this, that egress well needs to get installed somewhere in the mix between insulation, waterproofing, and backfill. Now we have a detail that we've designed out that has worked for us at least once at this point, but we've got a better material that we're going to use now. But it's basically a 4-inch light gauge metal C-channel, and the C-channel will get bolted with a concrete anchor right to the concrete on either side of the foundation, or on either side of the window opening. And then we want that installed before waterproofing happens, because we want the waterproofer to be able to come up and flash over the top of that flange up against the foundation on both sides. And they've got the Tremco line of products. They've got a mastic product that's used to bridge larger gaps and to fill some cracks, and what we've always had them do is use that on the flange of the egress well. And what we used to do before we needed the 3 inches or 4 inches of foam down below grade was that we would just bolt that egress well right to the concrete. But then what we're doing is we're losing a clear space between that egress well and the window opening of 36 inches. So what we're doing is we're just bringing this thing outboard a little bit. This C-channel that you're gonna install, if this is your concrete wall and we're looking in plan view here, this the C-channel basically will sit like this, bolted into the concrete, and this will be your rough opening for your window. We'll run the first layer of insulation into that channel, the second layer of insulation into that channel. And then we'll have a bolting surface out here for the egress well to attach to.
So you're not concerned of thermal bridge?
Well, there's a thermal bridge no matter what we do.
Unless you put it outside the insulation like we did.
Is it that significant?
Well, so the thermal bridge that we're going to have, if we have a thermal bridge, let's say if the egress well is attached there, it's the same thermal bridge. And if it's out here and we put a bolt through there, we still have a thermal bridge, right? And this surface right here, I mean, you'll see this photo when we talk about thermal bridging, the reality of the construction here. With all intentions to be perfect, that's often the case what ends up getting done, right? And so to some extent, we're trying to provide a better opportunity for these details to get dialed in a little bit closer. But the main thing there is we're just trying to get a solid mounting surface to bring that thing off the foam, 4 inches. And then have a detail for the window on the inside. Now, inside the window, well, we don't want any insulation installed. Not till the window's installed. Okay. So what you're going to have the foundation insulation contractor do is leave the pieces there that would fit in there, would cover that space, because you're going to need that material, but you don't want it installed, because you're going to need to integrate and run the membrane up over that opening, all the way up the wall, and get all your flashing installed above that window, and then you're going to re-insulate over the top of that. Does that make sense? Some of the details that, if you haven't done exterior insulation systems before, that become a little bit of a pain in the ass, is this reality that, you know, we still got backfilling and rain that occurs, and so the top of that foundation insulation gets destroyed and damaged and separated. A lot of times we'll find the layers got gravel in between them, so they're not sitting up tight against the house. So there's sort of just logistics to consider as you bring the wall insulation down to marry up with the foundation insulation. This is one of the components, just a photo of what would typically happen. There's been some question and concern about like the pier footings that are outboard of the insulation that are carrying the deck. We've seen the contractors adapt and do a number of different things. On the drawing, we've got it designed as a half-round sono tube taped to the foundation, or taped to the foam, backfilled, and that has worked. But we also have built houses and have contractors that forget that piece altogether and have to come back after the fact and put these in. And so this is an example of where they just drilled down the side of the foundation and dropped a whole sonotube in. It's not that hard to do, but that would be what it looked like. And then here's an example, just kind of a side note, where you can see the deck ledger is attached to the house, is flashed in, the deck's not in, but then what will happen is the post will go up and actually carry the load. And that deck ledger there is just for lateral bracing, it's not carrying a load. Here's a detail of that deck ledger before the siding goes up.
Is it just hanging on the furring strips?
That's correct, yeah. More details of the egress wall outside. And that landscape fabric on the backfill. Placement of the sump pump in the middle of the foundation or the basement slab before pouring. Here's what can happen when we throw sonotubes out in the middle of nowhere. We end up tearing those out and just redoing them. Okay. Any questions on the foundation, below grade stuff?